Welcome back. So in this video we're going to get an idea of what the idea behind ANOVA is. So let's look at two data sets, and again what ANOVA is for is to determine whether samples could have come from populations with the same means or different means. So we're using samples to get an idea of populations, and what we're attempting to compare is the means of the populations, specifically whether they're all the same or not. So here's our first data set. Oh, and by the way, as I mentioned at the end of the last video, you're going to want to have 3 colors of pen or pencil to take notes in this video, because we're going to, essentially it's because we're going to be doing this sort of a graphical representation of this data set, and using dots, and you'll want to be able to see which ones are from A, from B, and from C. So color coding is the way to go here. Okay, so I didn't really give a lot of explanation in words, or any explanation in words to go along with this data set, but you kind of get the idea that someone's trying 3 different drugs, and they're measuring some sort of response in the person, and the idea is we want to see if the average response to drug A and drug B and drug C are the same. Now, let's get the average response for each of those. Pull a calculator up here. Okay, so for drug A, we don't really care what these numbers mean, so I didn't say anything about them. So for drug A, we have 4 plus 5 plus 6 plus 6 plus 4. That was 5 numbers, so I'm going to divide by 5 to get the mean. Okay, so we get a mean of 5. I'm going to call the mean for drug A, I'm going to call it A bar. And I'm going to use red for drug A. And then for drug B, 7 plus 8 plus 9 plus 7 plus 9, 40 divided by the 5 numbers is 8. Okay, so I'm going to call the mean for drug B, I'm going to call that B bar. That came out to be 8, and as you see, I'm using blue for drug B. And then for drug C, let's see, I have 10 plus 10 is 20. 11 plus 11 is 22. And then we have plus 13. We get 55, divide by 5. And the mean there is 11. Okay, so C bar, and I'm using green for C, is 11. Let's go down and get the means for the second data set as well. And I've set these up so that the means actually come out to be the same for each drug. So if you go 14, let's see, 14 plus 4 is 18, plus 7 is 25, plus 0 is still 25. Divide 25 by 5, and we're going to get 5 for the average. And I want to use the same colors. So again, in this sample set, the mean is 5. Drug B, again, I set these up so that you'll get the same mean. So I don't need to keep doing these to convince you. 13 plus 15 is 28. Plus 7 is 35. Plus 5 is 40. Divide that by 5. You get a mean of 8. And if you compute the mean for C here, again, you'll get the mean, which I'm going to call C bar again, is 11. Okay. Now, what I'd like to do is a graphical representation of each of these sets. And you guys in your notes have a straight line that's a number line, intended as a number line to the right of each of these. So that's what we're going to be filling in now. And I didn't have room for that, so I'm going to go off to a separate piece of paper here. And I'm going to draw the number line in a neutral color. I guess I'll go with my black. Okay, so you've got 2 number lines. one to the right of the first data set and one to the right of the second data set. And we need 7 marks going across them. So 2, 3, 4, 5, 6, 7. And then let's try to line up the marks, because we're going to do sort of a visual comparison between the two data sets, the sets of dots. Okay, and these are even numbered markers. So 2, 4, 6, 8, 10, 12, 14, 2, 4, 6, 8, 10, 12, 14. Okay, now we're going to put in the dots for the data sets, color coding them so we can see which is which. Okay, so here's my first data set. Can I get this up so we can see it? There, okay. So for drug A, and I'm using red for drug A, doesn't matter how you color code things, but it might be easier to follow along if you use the same colors I do. But anyway, so drug A, one person had a response measurement of 4, so I'm going to put a dot above the 4 that's red. One person in that sample had a response of 5, so I'm going to put a red dot above the 5. Then we had 2 that had 6s, so I'll put 2 dots above the 6, and then one more person that's a 4, so I'll put another red dot above the 4. And then underneath the number line, I'm going to mark the mean, which was 5, so I'll put a dot there. So again, what I'm doing here is these are the I'll write it over here. These are the data points, and down below we're doing the means, one mean for each sample. Maybe I should call these sample data points. I don't know. Means of each sample. Something like that. You can put whatever explanation makes sense to you. Okay, now for drug B, let's say I used blue for drug B, so I'm going to make dots for the sample data points in that sample, and then below the number line I'm going to put a dot for the mean of that sample. So let's see, we have for drug B 7, so I'm going to put a blue dot above the 7, 8, put a blue dot above the 8, 9, so blue dot there, 7, that gets another blue dot, 9 gets another blue dot, and then the mean is 8, so I'll put a blue dot below the 8. Then the last set of responses in this data set, the one for drug C, I'm going to use green for that. So we have two 10s, so 2 green dots above the 10, 2 11s, so 2 green dots there, and 1 13, so green dot there, and the average or mean was an 11, so green dot there. Okay, so before we go on and do the second data set, let's just look at this, and again we're asking ourselves, do the 3 populations that these 3 samples come from, so the population that's represented by the red dots is the total population of results of drug A, but we only have 5 results. Okay, so this is a sample. There certainly weren't just 5 people in the world who took drug A. Anyway, so the red dots are our best representation, that they're what we have of the population of people that took drug A. Similarly, the blue drugs are a sample of the people who took drug B, therefore they're what we've got in terms of information about that population, and ditto the green ones for drug C. And what we're interested in is, on average, are the results of the 3 drugs the same? Now the sample means are different, but remember that each sample mean is just a point estimate of the population mean. We've seen that, you know, when we do confidence intervals, sometimes that confidence interval ends up pretty wide. So, you know, it's a wide region around the point estimate where the actual population mean might be. So just this point estimate doesn't tell us a whole lot. But in this case, you look at the way our samples are clustered, and it looks, if you compare the sample to the mean, it really looks like the population for drug A is clustered in this region and probably does have a mean that's different from the mean of the blue dots, because they're clustered in a different area, and so it's natural that they should have a different mean. And again, we're hoping our samples are reasonably good representations of the populations. That's always a big issue. If your sample's not a good representation of the population, then the results you get with the sample are not going to be good. But we're hoping that these are good representations. And if they are, then it's pretty clear that these are three very different populations that would naturally have different means.